Okay, so moving on to the next topic. So we have your average shear stress, or so it's called average because it's not deeply calculated each part sa inyong material, but since it's just what we call a simple stress, so what the stresses experienced are just average or na mga normal na mga kuan, na mga calculations. So we go to average shear stress. So forces, so if you see the figure, so forces P and P prime are applied transversely to the member, meaning transversely opposite to the other. As you can see here. So, so corresponding internal forces act in the plane of section C. So meaning, mo pass through dire, di ba? So probably the material will experience some deformation at first. So since this one is going upward, and then this one is going downward, so probably marag mo ana siya, di ba? Due to some kanang forces experience sa inyong member. So of course, if your material is super rigid, so and then super siya, super durable, so it probably might experience some or minor deformation, but dili siya super grabe nga deformation compared to some kanang malleable na materials. So of course, upon impact, so murag diretso ra siya ang iyang shearing, di ba? Okay, so the resultant of the internal shear force distribution is defined as the shear of the section, which is equal to load P. So probably if you try to cut down the material, so if this one is the P, so let's assume that P and P prime are equal in terms of forces. So we can say that the shear of the section, let's say V, is equal to P prime. So more siya same as what we have discussed last meeting on normal stresses katong magkataog plane, but kato siya is just normal, di ba? The force is perpendicular to the area. But this time, if you notice that once we cut at section C, so the force is now parallel to the area. Di ba? So marag ni-slide ang inyong force with respect to the area of contact. So in terms of formula based, so as you can see, the shearing stress is just equal to V over A. So again, as what I mentioned before, so isa ra dyan na siya ka formula for your stress, which is stress, whatever stress you are declaring, whether it's normal stress, shear stress, tangential stress. So you can just declare it as a subcomponent, let's say sigma, then subname. So marag in general lang siya ba? Then force over area. So again, the force will depend on what type of shear you are, I mean, what type of stress you are declaring. Then the area is, of course, will also be mag-agad siya sa inyong stress na inyong gi-declare, di ba? So far what we have discussed from last meeting was just normal stress, di ba? So the force is perpendicular to the area. So for example, this one is your contact area. So this is the force about perpendicular to the area. So this time, if this one is our area, so the shear force is parallel to the area of contact. So nanatay bago, di ba? Nanatay next na pod na stress na nahibawan aside from normal stress. So as long as you can imagine that the force is sliding across a specific area, so that is what we call as shear stress. So if it's pushing, the force is pushing against the material, di ba? Perpendicular siya. So that is normal stress. So of course, there are other advanced na mga forces, labi na combined stresses, which we will discuss on the later part of the semester. So for now, let's stick to the basics first, and then we try to progress through the advanced topics. Sorry. Okay, so again, as what I have mentioned earlier, so your shear stress is just acting along, or it's parallel to the area of resistance. So forces acting along or parallel to the area. Okay. Okay, so it's also caused the applied loads cause one section of the body to slide past its adjacent section. So most likely what this segment um, means is that, so usually sa mga bolt systems, so dili man na ingon na two areas lang, di ba? But you have the bolt, you have the washer, and then you have the katong metal plates na gi-attach sa katong bolt, di ba? So of course it's not only one body, but there are several bodies that tend to slide on the adjacent sections, di ba? So it may be that the bolt body is sliding along the katong metal plate, di ba? So it could be in that format. Okay, so shearing stress across the section is practically never uniformly distributed. So shearing stress is difficult to create as a uniformly distributed load because since most likely shearing occurs on small materials such as bolts or kind of mga connections, and usually we see normally distributed load as a normal force, di ba? Kanang murag perpendicular siya sa inyong material, bali nakapatong siya. So it's never really sliding. So the uniformly distributed load is never really sliding, di ba? So if it's sliding, so most likely the weight is still um, applicable to that area, but muna siya. Marag wala kay siya na-cause na kuan ba, na stress, di ba? So most likely shearing stress is direct, or it's kanang katujong murag concentrated force as per your static of rigid bodies na topic. Okay, so it's interpreted as the average shearing stress. So pwede ra po dili siya average, so libog kayo no, magbutang pa siya average na when we think of average, it's just the kamog forces then yung average na. But the average here is to simplify that the shearing stress is a concentrated load na. Muna siya ka nang gi-concentrate lang dito ba? Para di mo magdagan og unahon na. Okay, so we have different types of shear stress. So we have the single shear. So as you notice in the figure, so let's say this is the bolt connection among two different materials. So as you notice, the shear will occur on the bolt, diba? Kay if you are looking for the failure part, so most likely that the material nga mo fail is this bolt, diba? And kung saan niya pag-fail, so I think you can imagine the area by imagining where the material will fail. Diba? So again, as per formula, shear stress tau is equal to V over A. So again, if you're going to imagine kung asa siya mo fail, that will be the area automatically for your solution. So upon looking at the figure, so if you try to imagine the bolt, kung asa siya mo fail, so mo fail siya likely in this area, di ba kani siya? Di siya maguba. So of course, we don't have to be super strict na, sir, ini ka fail sa shear, kaya dili siya perfect circle, ana. So of course, for simplicity's sake, pwede tayo maglisod og solve. So ato siyang i-circle lang, di ba? Kasi mag-imagine mo, inika-break niya kay diagonal din siya, di ba? So meaning, ang inyong surface area noon is oblong, ana, di ba? So let's try to make things simple by, so even though that the failure is not clean or it's not a perfect cut, so of course the contact area is, we try to imagine it as a perfect polygon. So in this case, it's a circle. Okay, of course we try to make boats as circle as much as possible, but of course na po yung mga boats na dili po circular, di ba? So sige lang, i-mention mo na sa problem. Okay, so if we try to cut it, so notice that the force will be directed towards the bolt. If you try to cut some section here, but internal force, and if you even cut it further with regards to the bolt, so the force will counteract the external force F. Ang counteract niya internally is the shear force P. So notice that concept, di ba? Nilain na po ng iyang variable. So moto para di mo maglibog, kato lang siguro ana, stress is equal to force over area. So I think duha ra na siya kabuk sa kung, as far as I remember. So this just this one, normal stress, and then this one is the shear stress, ana. Duha ra na sila kabuk. And the other types of shear will be represented as sigma, but naala siya kanang sub name na sigma sub something. Okay, so force over area. So again, the area of contact will be the one where the shear force is sliding. So this is the area of contact. So now we have P over A. So of course, since we assume that the distribution of the external force internally is equal, so pwede na po siya diretso, di ba? You might declare it as F over A pod, or whatever the given external force is in the problem. So of course, it's not totally applicable right away if you are given an external force, but I think this one is only applicable if your system is in equilibrium. So meaning balance ang system, ana, ang forces is balance sa left and right, ana. Okay, so we also have the double shear. So as you notice here, if you imagine again the failure of the material, so the failure will be experienced on this portion here. So double shear means you have two area of contact. So meaning on this portion here and on this portion here as well. So double areas, yeah. And of course, if you notice that since you have a double area, so meaning you have two sliding forces, so most likely your P here and the P here is equivalent to F over 2. Diba? So if you try to, if mo na siyang F going towards the right, so it must be resisted equally by the P forces internally. Now, since there are two contact areas, so meaning half ang forces diri sa babaw and diri sa ubos mo na F over 2 siya, di ba? So the formula is this one. So pwede ra po siya kuan P. So again, I just put this one here kay para kibota nga ang inyong kuan, ang inyong internal force is P is F over 2 siya. Muna, if you try to solve just one aspect of it sa double shear, so yeah, so this one is P over A, only concerned with one area. But if you're going to use the external force, so that's F, then since it's going to be two areas, the totality of the force, So that's being experienced by two areas muna F over 2A siya. Okay, double area man, di ba? So dagan na kay arrows no. So I hope you follow the discussion. Okay, so questions so far.
None so far, sir.
Okay, so we try to okay, so these are examples of the shearing behavior. So notice that muna siya ang shear, di ba? So the failure here, the failure of the stress here is on this core portion. So this will be the area, di ba? When you try to calculate your shear stress. So in actual practice, when you try to go to, let's say, steel design, labi na sa mga bolt connections, so daghan kayo mo i-consider na mga stresses aside from shear stress, napay bearing stress, punching stress, and other types of stresses in design. So if you look at the let's say this one is a portion of the truss connection, bolted truss. So you have different parts coming into play into your bolted connections. So you have the cap plate, you have the flange as well, you have the pin, which also experiences the shear stress, and you also have the gusset plate. So daghan kay siya kanang elements na mo come into play sa inyong shear stress. So of course, you always try to imagine the behavior of the force so that you can imagine what type of stress you are going to deal with your material. Okay, so for example, this type of um, structure experiences this type of force. So let's say 160 say kilonewton or kips. So since you have two different members, so of course this will be experienced by the two connections kanisha. So that's why we have P over 2. And then of course, if you try to again imagine the different types of stresses, so this member will experience normal stress, and then this bolt will experience shear stress, diba? As far as we have been discussing stresses. So kana pa to nibawaan, diba? Wala pa ta mo go into details about the bearing stress and the katong other stresses. So kana kala na sa tong nibawaan, diba? Okay, so for example, we try to um, determine the stresses on in the connections of the structure shown. So let's try to borrow the example from the normal stress problem. So hopefully you have still know the answer to the different forces. So so ako lang sang i-check ang ko ana ang atong answer kay nakalimot sa go. So that would be so 40 for AB and then 50 for BC. Okay. Okay, so going back, so if you look at um, the front view of the example last meeting, so di ba murag alam mo to ang dagway sa to ang figure, di ba? Yan na ay 30 kilonewtons diri ana. Okay? So if you look at joint C, so let's say the internal force here is 50. 50 ba to? 50. So internal force here is 50. So if you try to isolate the area, so ang ma-faila ng portion is kani, di ba? Kani ang bolt, ang pin connection here. And notice that the area is 25 mm in diameter. Okay? So if you try to find the stress at joint C or at the pin at joint C, so that would be V over A or P over A. So that would be 50. So since we want our answers in megapascal, so you have to make this in Newton, 50,000 newtons. And then the area, so again, 25 millimeters. So pi d squared over 4. Or if you're not comfortable with using the diameter in the formula for the circle, so you're going to use the radius pi r squared. But mo gyapon mo divide gyapon mo 2, di ba? So 25 over 4 squared. And I think that would be the answer in megapascal.
101.86, sir.
101.86
86.
megapascal. Okay, so that's the answer for joint C. So this is the shearing stress nga ma-experience sa kaning area. So mura man siya ang mo-break, di ba? Mura siya ang mo-fail. So always try to imagine which portion ang mo-fail. Okay, muna siya ang mo-add to sa area sa inyong formula. So let's try to skip first joint B, because if you try to look at B, so it might be complicated because aside from it's connected towards joint C, so it's also connected towards joint A, di ba? So probably this one is experiencing 50, di ba? And then ang kaning inyong kaning siyang forces nimo dire, kani going towards A man siya, which is 40 kilonewtons, di ba? So daghang kani siya og factors na come into play sa inyong forces. And we'll try to break it down later after solving joint A. So on joint A, as you can see, as what kung tanaw ninyo, double shear siya, di ba? So itugma ra to ang i-discuss kanina that we have two types of shear. So this one is single shear, and then the other one is double. So again, you can always try to imagine the failure type sa material para kibaw mo unsa ang iyahang type of stress. So as you can see here, you have double area. So coming from the last problem, so let's say it's 40 kilonewtons as per the slide. So if we try to isolate this one, if we try to isolate the bolt, so if this one is 40 kilonewtons, so it will experience a 20 kilonewton force on the opposite side, diba? And again, since it's a double shear, so again, by formula as per previous slide, so you may use just one force, which is one force and one area, let's say P over A, or you may use the full force, but it will be divided into two areas. So you may use 20,000 kilonewtons all over pi. So again, the bolt is 25 millimeters gapon. So it's not the 25 na kani. It's not also the 30. And it's not also the 25 above, but it kani siya nga kuan because muna siya ang material nga ni fail. So pi d squared over 4. So 25 over 4 squared. Or again, if you want to utilize the full force, so that would be 40,000 all over 2 times pi 25 over 4 squared. And this will be your shear stress at A.
40.74, sir.
40.74. So megapascal. So this again, this is just on joint C and joint A. So later on, we'll try to analyze the shear stress at joint B. Kay murag again, since it's being connected by different parts coming from C and coming from A, so we need to dissect which stress or which force governs the whole system at B. Diba? Okay, so this one is coming from the previous example, so you may try to review the last recording. So 40 and then 50 kilonewton for the internal forces of force or member AB and BC. Okay, so this is the answer that we are that we have calculated earlier. So again, if you're not comfortable with using diameter as for the formula of the area, so you may use the standard formula, parang pinaka high school jud na formula, which is pi r squared. Yeah, sa akong experience, most likely on the design books such as reinforced concrete and reinforced steel, ang pag-solve sa area is kana jud mark pi d squared over 4. So mag na-retain na siya sa akong utok, pi d squared over 4 ang gamiton. Okay, so this one is the area. So again, this might seem a different approach sa calculation, but ang style is that iyang gi-convert into meter square ang area. Okay, para Newton over meter squared. So Newton over meter squared is megapascal. So earlier atong ibuhat, it's Newton over mm squared. Newton over meter squared is just Pascal, but Newton over mm squared is megapascal. So you might ask if how many decimal place ang pangayon during the exam. So pinira duha. So di na ko mo super strict with the significant figures. So the 2 decimal places lang ang pangayon. Okay. So let's go to the shearing stress at joint B. So as you can see, daghan kayo ng kuhan, di ba? So you have different na mga forces here. So 20, 20, 15, 20, and then 15. So magdaghan na kayo, di ba? So this 20 here, so let's try to dissect each part. So this 20 here is coming from asam nagikan. And then asa po ni siya gikan kaning 15. And 15 sa, di ba? So let's try to break it down first. So again, since let's say this is joint B, and notice that in the previous problem, let's look at the figure first. So there's a 30 kilonewton, di ba? At joint B. So again, since our system is symmetrical, or we consider it as kanang equally divided, di ba? Or let's say it's equally symmetrical, meaning ang ihang dagway is if imong i-half is the same as kanang the left and on the right. So this one is just 1/2 of the external force, 30. So that's why it's at the end of the pins, 15 and then 15. So if you add this one up, that will be 30. Okay, so next question is 20 and 20. This is coming from joint member AB. So that's why you have 20, 20. So asa man ka ng force BC nga 20. Di ba ang ato ang force BC is 25. So if you try to recall so since this one is diagonal man, di ba? Is diagonal 20. So if you try to break down the different forces again into its horizontal and vertical component, so you might be able to see why it's 20. Magdibi ko ka-erase. Let's say if maka-erase ko. Okay, so divide the pin sections to determine the section with the largest shear force. So let's say ato siyang i-divide. So this one, E, G, and H. So DE and kani siya nga segment here. So atong ikaw na. Let's try to create another color. So kani siya nga portion, kani siya DE, and then J, so may siya H, JI. So let's say this one is I, and JI are those coming from AB. Ana. So meaning paana siya dire, di ba? So ako lang exaggerate. Kaniding EG day, EG I mean, rather EG and then HI day, HI. Dili day. So HI day, HI pa dong dire. Now GH is the force coming from atong member BC ana, di ba? So maglibog siya tanaw, no, but again, if you try to look it on the top view, so if you look at it at the top view, so muna siya yung tagway, di ba? Masama to. Maginani ang dagway niya, di ba? Kani siya. But nala is kaniday. So kanisha is going towards AB, and then the other one is going towards BC. Okay, so divide the pin at P into sections to determine the section with the largest shear force. So at PE, let's say this is PE. So you have 1/2, so we have 15 here at E, diba? And then at this one is at G na po ni siya. So daghang kay forces nga mo come into play, diba? So medyo maglibog ta kung sa atong gamiton jud. So kani siya at joint E. So we have only the 15 kilonewton force, diba? If you separate this portion here, kani siya, mura na siya ang mo-govern sa inyohang area diha. Ay inyohang shear stress diha. So 15 ra. But if you go deeper into the material, let's say at joint G or cross section G, so notice nga nanatay daghang forces nga mo affect sa inyohang system. So you have the 20 kilonewton force coming from force AB. You have, so I think this one is 25 ni siya, dili siya kuan. Dili ni siya 20, but this one is 25. And then 15, ba? And then the shear force coming from the material above is 25. So this one is 25 from kuan na siya from force BC. Kay 50 man atong force BC, di ba? So again, the member na atong diagonal is 50 kilonewtons. So again, regardless of its direction, so since it's striking the same area laterally, or let's say on kana shearing ang iyang application is parallel, so it's 25. So among the three, so you have 20, you have 15, you have 25. So 25 is the largest. So this will govern on the maximum shearing stress. So you have 25 divided by the area. So we all know by calculation from the previous slide that is 25. So 25 divided by area is 50.9 megapascal. So this is pi d squared over 4. So you may write this one as 25,000 kilonewtons. Para mo na siya ang labas sa answer. So again, if you're trying to answer kaning mga pin connections having different connections, malibog na no? If you're trying to solve the shear stress at a specific joint having many connections, so meaning example at joint B, so since daghan siya og mga forces nga na-experience, so might as well cut it at the middle. Na kani siya just for the sake of discussion, so we cut it first at the first end. Para kanang first connection coming from force AB, but usually ang my experience yun sa material with multiple connections nga dako og stress is at the center dyan na siya. So that's why we focus more on this section here. Ano siya? Okay, so again, regardless of direction, so murag I think dili kay mo affect greatly ang forces, but for equilibrium purposes, so probably it will affect the kuan. It will affect the condition of the kuan kaning inyong pag-solve sa mga forces as well. So I think just try to check if 25 ba jud ni siya, kay try resolving na lang siguro into its corresponding horizontal and vertical. If equilibrium siya, so meaning sakto ra ato ang pag-solve. Okay, probably murag na ni kan siguro 25. Okay, so any murag confused no, or do you have questions or clarifications?
None so far, sir.
Okay, so we move on to the next, which is bearing stress. So we have another type of stress. So okay, so let's say we have this particular formula. Oh, sorry. So to break it into simpler terms, so most likely the bearing stress is the failure between the contact of two areas, but the failure is not coming from one material but on the other material. So that's why ang inyong area is kaning area of contact dire, kaning murag kani siya. Murag ayang contact, I mean ang iyahang failure is on the on the other area dili sa bolt. So di ba sa shear is, let's say ang inyong failure sa material will be coming from the bolt. But what if dili mo fail ang bolt? Kusgan kayo yung bolt, but it will create some deformation or some stress on the material that it is supporting. So meaning ana, since magduot siya dire, so magduot po na siya dito, di ba? And the circumferential area nga inyohang sa pagtuod sa bolt sa kanang specific area, that would be the contact force or the area of contact sa inyohang stress. So that's why it's T times D, di ba? Mura siya kanang rectangle ang iyahang kuan. Rectangle ang iyahang pagduot sa inyohang material. So thickness times the diameter. So mura siya rectangle, di ba? So mura siya inani ang kuan. So if you try to create the cutting plane, so muna siya, di ba? T times the diameter. So of course, that thickness is not coming from the bolt, but it's coming from this area here. The thickness of the material, and then ang iyahang pagduot is of course coming from the diameter of the bolt itself. So that's the area of contact. Okay, area of contact na atong concern, di ba? Dili kaning cross-sectional area sa inyong bolt. So again, always remember that force over area, force going towards the specific location or specific area. Area is always the contact area, regardless of its normal or shear or bearing stress. Okay, so clearly defined, it's a contact pressure between separate bodies. So that's the highlight term there. So separate bodies. Okay, so bolts, rivets, pins create stresses on the points of contact or bearing surfaces of all members they connect. So ayan pasabot ani is it's not only that the bolts are experiencing stresses, but as well as katong mga joints, katong mga kuan nga ilang gi-connectan, di ba? So I think if you imagine nga if naay magsandig ninyo, di ba? If there's someone leaning on you, so of course it's not only that the person is experiencing stress by creating stability nga nag-lean siya niyo, di ba? But as well as ikaw, di ba nga nagdawat sa iyahang load. So just try to think it in that manner para dili kay siya lisod isabton. Okay, so the resultant of the force distribution on the surface is equal and opposite to the force exerted on the pin. So same concept as your normal stress and shear stress. So it's equal and opposite. So meaning you need to create equilibrium on that specific portion of that stress. Okay, so average force intensity is called the bearing stress. So again, go away with the average term. So you can just call it as bearing stress. So far we have now three types of stresses: normal stress, shear stress, and then bearing stress. Okay, so let's try to again solve the same problem, but this time is we're going to solve the bearing stress. Okay. Okay, so if we try to solve for the bearing stress, so I think ang inyo harang ma-experience ka bearing stress sa kaning material is at A, and then for B, so probably we don't know yet the behavior at B, but for A, we're pretty sure nga maka-experience siya og kanang bearing stress. But let's see lang as we go along the process of answering it. Okay, so this one is the kanang the zoom area for joint A. So again, the plate or the member AB is 50 millimeters in diameter. So di siya yung diameter, so we're not sure if it's circular ba yung member or dili. So this is the side view of the material at joint A. And then this is the top view kaning nasa lower nga figure. Okay, so if you try to imagine where the failure of the bearing stress is, so asa man ang bearing ko na, where do you think the bearing will happen? Sige daw, let's try if okay, so the bearing will happen on this material here kani siya. 30 and then 25. So sama na siya pag pag maglisod sa ko og drawing, sama na siya pag drawing. So the failure will be on this material here kani siya. So again, it's not shear because it's not a failure concerned with the bolt or this cunning pin here. So if it's concerned with the pin, so meaning the failure will be shear stress. Now again, since kuan man siya kanang the failure is in the other material man, so meaning ana this would be the failure portion here kaning member AB kani siya experiencing the 40 kilonewton na load. So murag di kayo maka-imagine, no? So just try to imagine unsa na siyang bearing stress, or if apa mo kita og bearing stress nga behavior, so try to look for some videos sa YouTube kung unsa jud ka ng mga deformation sa bearing stress. Basta as long as what I can say is that the failure is on the other material jud. So if one is experiencing shear stress, the other material will experience bearing stress. Okay, so to determine the bearing stress at A in the boom AB, so meaning the connection or the member AB. So we have the thickness at 30 and then the diameter at 25 millimeters. So again, this thickness is coming from member AB. And then this diameter here is coming from the pin. Diba? As I think this one was shown in the previous slide na ang katong contact area for the bearing is katong area sa katong plate, dili sa kuan. But of course, since the bolt is also pressing towards the kanang kuan, the area of the material, so maka-affect po tong contact portion sa inyohang pin. So if kuan, so muna siya. So let's try to go back a few slides. So muna siya, di ba? So the diameter is coming from the bolt, and then the thickness is coming from the material. So muna siya. Okay, so the stress at B, so meaning at boom AB. So murag gikuan lang siya sigma sub B lang siya. So notice again, di ba? Ang atong igamit na variable is sigma, but it's na siya subscript na B, meaning it refers to the bearing stress. So pwede na po ito niyo ikuan sigma sub S ana, or pwede po siya sig tau. Usually tau dyan na siya ang kuan sa inyo ang shear stress. So again, from the previous problem, we know that this one is 40 kilonewtons. And then again, by definition, so this one is 40 kilonewtons again. So again, the contact points of the bearing stress is this one, di ba? Kaya muna siya ang mo-fail. Mabira siya pa doon dito, di ba? So that's why you have 40 kilonewtons in the force times the thickness of the material and then the diameter of the bolt, which is 25. So muna siya kanang rectangle, di ba? Na contact area is, let's say kani siya na padong dito ana. Wag na mahatak siya padong gawas ang material. If ever nga dili mo fail ang bolt, di ba? So if mo fail ang bolt with regards to the 40 kilonewton force, so meaning it will experience shear stress because the pin failed, di ba? Shear. If this member here failed, that would be bearing. So of course, if one experiences the stress, so if one experiences failure, so meaning ang isa ka member di na siya mo fail, diba? So for example, this one is shear failure. So meaning di na siya mo fail ang member. But if na may bearing failure, so mo fail ni siya, but ang inyong pin is solid pagyapon. So mana siya. Okay, so napatay isa dere. So determine the the bearing stress at A in the bracket. So this one is the bracket. Okay, so our thickness is twice 25 mm because this one is the area now. So let's say mo fail siya. So again, since we have 40 kilonewtons going to the right, so going to the left po ni siya, di ba? So if ma-failing ang material, so meaning na tibuok pa inyong pin, tibuok pa inyong member, ang ni-fail ani nga portion is kani inyong bracket kani siya. So 40 kilonewtons, and notice that the thickness is now 50 because 25 plus 25, because that's the amount of failure that the material will experience. And then 25 coming from the diameter of the pin. So kanigi ka na siya sa bracket. So that's 2 times 25 na siya from the bracket. Kani siya coming from the pin. Naman ni dire dai, naka-show man ni dire kani siya. Okay. So of course there are still connections sa point C. So just try to explore the bearing stress on that particular aspect. Okay, para inyo makita ang behavior. Sa joint B, since it's overhanging, so most likely shear stress ra yung ma-experience kay one of my other material nga mo fail, di ba? Pwede po katong napunta sa B because naa siya kanang kuan. But just try to look for the kuan lang, the answers. Okay, so let's check if pinapatak slides. Okay, so before we proceed to the next stress, so do you have further questions?
None so far, sir.
Okay, so probably maglibog po siya karon kay kanang kaning maglisod po ta og imagine sa material because since drawing raman ta and then there's no physical material present. So as much as possible, try to imagine it on your own. So I suggest that you kuan siguro you buy some kanang clay guro na clay. Ya na idututin niyo na or inyong inyong i-push and pull para makita niyo ang behavior sa stress. Or you can also try to use ruler, katong mga gagmay nga ruler, mga 6 inches. Ana. Try to bend it, try to pull it, try to push it. Ana. So I think this is the last pressure that we're going to discuss. So pressure or stress are the same. So I think pressure is more used on the physics aspect na term, di ba? Okay, pressure is still force over area if you want to go to physics nga aspect. So we now go to thin-walled pressure vessels. So this topic might seem murag not really that important if kanang dili ka mo fully appreciate sa kaning topic. I think usually for thin-walled pressure vessels, this topic is more applicable on the chemical engineering students because since they will be storing chemicals sa mga storage tanks na. So those mga liquids, di ba? As per I think mo may mga mga specific gravity. So I think with respect to the different kinds of liquids, so mo differ po diyang weight, di ba? Yeah, I see the specific gravity. So for example, mercury, di ba? So mercury is a liquid but it's heavy and so some store some gases, others store some liquids, di ba? So natin mga liquid nitrogen and ana. So I think that's the importance of this topic. So especially when you are also trying to um, try to create your support for your water tank sa inyong balay. Na, di ba naman ay patunganan ninyo ang water tank, di ba? So, di siya basta-basta pag-create, di ba? But it's calculated because if the tank is full, so mo create siya og pressure sa inyong supporting structure as well. So I think that's the importance of this topic, kaning thin mold pressure vessels. So try to appreciate it as much as you can. So muna siya, pressure in cylindrical tanks. So most likely the pressure will be in all directions, X, Y, and Z. So one will be experiencing lateral pressure, one will be normal pressure. So X, Y, Z ang iyahang kuan, ang iyahang component. Okay, so super daghan kayo. So tangential stress and longitudinal stress will be the type of stresses that we're going to answer here in this topic. So tangential stress, so meaning tangent, di ba? Tangential stress. Longitudinal, so that's kanang padako, I mean lengthwise, di ba? O if you're going to imagine it sa in simple aspect, so it's going to be lengthwise and crosswise na kanang shearing. I mean not shearing but ayang stress kami experience. Okay? So tangential stress will be concerned more on the tangent aspect of the one. So of course, for simplicity's sake, we try to understand it in this manner nga murag straight lang siya but dapat ang iyang forces will be tangent to the circle, di ba? Circle or semicircle depending on the cutting plane. Yeah. So next is the longitudinal stress. So it concerns more on the kaning material of the thin wall on another aspect. So if you try to break it down, so ang tangential is going on this direction, going masya ka ng normal stress, di ba? normal stress ang iyang dating kay murag siya nag-push sa kuan, di ba? Nag-push siya sa inyong tank. Ang inyong other stress, longitudinal stress is ang iyang forces is kanhi pod siya diri dapita na pinaka-simple na siya nga explanation. So probably I think the basic way to explain this is kani siya is more concerned on the weight. And then this one is of course probably concerned with the kanang with the liquid or the what is inside the tank. So of course they may vary because magdepende siya sa kanang kuan, di ba? Sa orientation sa inyong tank. But nevertheless kung siya nagatubang basta ang tangential stress is inside, di ba? Inside the tank. Longitudinal is concerned with the outside. Murag pressing outward, and then longitudinal is mura siya gi-stretch, di ba? Stretching or compressing. So of course, if you imagine ngano mo stretch mo siya or ngano siya mo compress. So again, just imagine the different types of liquids nga inyong i-subject ang inyong tank. So it could be liquid nitrogen. So since it's cold, so it might compress. So if it's just water, like your water tank, and then it's exposed outside your house, so probably it will expand. So there are different elements na pwede nyo ma-incorporate sa inyong stresses. Okay, so this is the tangential stress. That's called the hoop stress. So muna siya, murag that's the inside of the tank. So if you want to look at the different I'm sorry. So medyo daghang kay siya og di ba? Daghang kay siya og formula to consider. But again, since we're not concerned with the derivation process or the integration part of the formula, so feel free to memorize this formula. F is equal to P TL. So D will be the inside diameter of excuse me. So D will be the inside diameter of the tank. L will be the whole span of the tank. And then P so I think P is say tawagan ni P gani. That would be the density of the water. Dili water but any liquid. Excuse me. Okay, so so again, just try to follow with the. So let's try to back lang siguro. Okay, para inyo makita ang flow sa derivation if you are concerned with the derivation aspect. Okay, so it starts with the cutting plane, section AA, and then you're going to have a differential angle to represent the differential strip with regards to the integration process. So if you remember the katong sector nga integration aspect, so mo to siya. So this is your differential F. That's the differential force because again, that only concerns a certain aspect of the tank, diba? So if you go back to your integral process, so muna siya inyong pag-represent sa whole material, diba? The differential area, the differential volume. So in this case, it's the differential force. Okay. So muna siya ang iyang formula. Okay, so for example, you have a liquid. So muna siya yung kuan, di ba? So this is the actual formula of the tangential stress. So katong earlier is, I think that was the force, di ba? Ang force ba to, no? Oh, that's the force of the tangential stress. So using force over area ang akuan nga technique, basic formula. So notice that even though we are now discussing tangential stress, the formula, the basic formula is always the same, di ba? It only differs in the force and in the area of contact. So muna siya yung i-remember always. So you can try to memorize one formula. So as sa akong experience sa review sa board exam, so ang gingon sa among reviewer is that there is only one formula for stress. So you just have to determine what kind of stress is it, and the forces and the area will follow if you understand the concept. Okay, so PD over 2T. Okay, so longitudinal stress, the force is pi d squared over 4 times the density of the liquid. So again, I think the density, kay murag, para nako, the density topic is discussed in fluid mechanics. So I hope that you have your fluid mechanics. So if not, I'm not sure if ano ba kay second year pa man mo, di ba? Second year pa mo? Third year? Third year siguro mo.
Second year, sir.
Second year day. Okay, sa among time before, ang among strength of materials is third year man. Sa mga maglilibog ko since you are in the new curriculum. Okay, so again, shortcut is that the formula is PD over 4T. So again, if you want to understand the derivation, so you may also do that one so that you may understand where you are coming from with the basic formula of force over area. So again, force over area, since it's longitudinal, the force is kind of perpendicular to the area, di ba? Ano siya? So we have pi d squared over 4 times the density of the liquid. So water, mercury have different types of density. So the force is, the pressure is pi dt over, the pressure, force, force, actually force. So the force is, kani siya? So you have force coming from the outside of the material, then coming from the inside, which is equivalent dapat because they will counteract one another. So that's why the formula is this one. Longitudinal stress is PD over 4T. So I think if this one is in Greek letters, it should be the Greek letter rho. So kana ailan nyo i-stress out inyong self sa pagsabot ani because again, para nako magdili kay siya much appreciated because again, magdili kita maka fully utilize sa kaninga type of stress unless you go into water resources nga specialty. Na kana guro pili guro kay you'll be having the dams, the kuan, mga water storages, but for structural aspect, probably not, but you are more focused on the shearing stress jud kanang mga shearing stress and bearing stress sa structural aspect. But for this kind, most likely chem-eng jud chem-eng. Okay, so we also have an additional spherical vessel. So same formula. So PD over 40. So as long as you know the different components of the material. So T with respect to thickness, D diameter, so on and so forth. Okay, so most likely in thin walled pressure vessels or in your tanks or in storage materials, so the stresses are assumed to be uniformly distributed. So we assume this one because since the inside is liquid or gas, and then it creates equal pressure or forces. So that's why we assume it to be uniformly distributed. So probably it could still be uniformly distributed even though you are mixing different types of liquid, but parang siya variation na iyahang di na siya uniformly distributed, but kato na siyang varying, diba? Katong triangular load ina na siya. Okay, so for cylinder, katong atong i-discuss kanina, tangential and longitudinal. So D is for the diameter and T is always for the thickness of the tank or for the cylindrical vessel. So here is for spherical vessels, the same formula as your longitudinal stress, but take note that T here is the thickness of the sphere. So magdali na kayo siya, no, if you're just going to memorize the formula, and hopefully that the problem is also formula based na problem, di ba? Like directly substitute lang inyong formula, but kanang basta kanang mga hardship during college ana sa una, mga lisod jud kaya pagamito pa mi og integral calculus para makasolve sa force. So I think especially if your teacher is engineer for nis ana, hilig siya ana mga problems nga murag ipa-integrate pa mo sa mga different components before arriving or before using the main formula jud. So mainana niyang style jud kanang pina big brains. So expect lang siguro if under mo niya sa kanang fluid mechanics. Okay, so cylindrical steel pressure vessel, 400 millimeters in diameter, with a wall thickness of 20 millimeters, is subjected to an internal pressure of 4.5 meganewtons per m squared. So again, meganewtons per m squared, this will be 4.5 megapascal. Calculate the tangential and longitudinal stress in the steel. So lisod na, no? So again, as per formula, T is the pressure, and then D over 2T ito, no? 2T. And then for longitudinal, that would be pressure times T over 4T. Okay. So just try to verify your answers. Good. So 45 megapascal for the tangential stress and 22.5 megapascal for the longitudinal stress. So next question is, to what value may the internal pressure be increased if the stress in the steel is limited to 120 megapascal. So probably if you want to solve this problem, so you start off with 20 megapascal and then try to reverse the process. So meaning the internal pressure is now the unknown parameter, then you're going to have 400 mm, and then 2 times the thickness. So magana siya nga dating. Okay? So if the internal pressure will increase until the vessel burst, so sketch the type of fracture that would occur. So I think I leave this one to you so that you can imagine what type of failure will the thin-walled pressure vessel experience. So para murag mo work sa inyo ang brains pa, di ba? Imagine mo ang mga things on how they go about once it fails. So ayun lang sad ang students mo fail, di ba? But ang material lang na. Okay, basin mag-imagine sad mo nga mo fail mo ana. So ayun lang sad. All right, so do you have questions? Further questions or clarifications?
Answer for sir.
Okay, so I think I'll leave this one. So it's not a homework, but it's just for reference on the recording later so that you may want to answer the problem on your own.
Sir,
So,
excuse me, sir.
ah,
Pwede may mangayo sa lecture material sa konse.
oh, mag-upload lang ko kay na-busy bit ako sa akong calculus. Nag-apas ko sa akong calculus kay kuan.
Sige, sir. Thank you, sir.
Murag kato siya mas kwanto siya mas sorry. Mas kailangan to nako i-kuan jud. Mas kailangan to nako i-focus ang akong calculus kay kanang